Welcome to qnawire.
Okay, so I'm reading chapter 29, problem 15. So we have a 22 centimeter diameter coil, and it's consisting of 28 circular turns. And it tells us the diameter of the wire is 2.6 millimeters. A uniform magnetic field perpendicular to the plane of the coil changes at a rate. So dB dt here is given as 8.65 times 10 to the negative 3 Teslas per second. Excuse me. Okay, part A asks, determine the current in the loop. Okay, so we know that there's an EMF induced in the coil since the magnetic flux is not constant. The current in the coil is the induced EMF divided by the resistance of the coil, which follows Ohm's law. Okay, so to do this, let's first find the magnitude of the EMF here. So this is just N times the area of the coil times dB dt. And we also can find the resistance of our coil by taking the density here times the length of the coil divided by the cross-sectional area of the wire. Okay, so now we know the current here is given by EMF over R. So this is NA dB dt over rho L A wire. Okay, so if we just plug stuff in here, then we can get 28 times the area of the coil, which is pi times 11 centimeters squared, times the cross-sectional area of the wire, which is pi times 1.3 millimeters squared. And our dB dt was 8.65 times 10 to the negative 3 Teslas per second. We divide this by our density, which it tells us was 1.68. Oh, it might not tell us. Might be that you have to look up some linear density of or resistance for a gold wire, and that's 1.68 times 10 to the negative 8 ohm meters. Okay, and now the length is 28 times the circumference, because it's a circle that goes around 28 times, and the circumference is given by 2 pi times the radius. Okay, now we have everything, and everything is in SI units. So this comes out as 0.1504 amps. And that is our current. Cool. What does part B ask? We want to determine the rate at which thermal energy is produced. Well, that's just the rate, or that's just the power, which is just given by the current squared times the R. Okay, so let's just do that. That's I squared rho L over A wire. So this is, oops, not 1.5, 0.1504 amps squared times 1.68 times 10 to the negative 8 ohm meters times 28 times 2 pi times 0.11 meters. And this is all divided by the area of the wire, which was pi times 1.3 times 10 to the negative 3 meters squared. Cool, so this looks pretty messy over here, but it's just these same things we plugged in up above, down again down here. And we get a power equal to 1.4 times 10 to the negative 3 watts. Awesome.